we are talking about ellipses. Okay, an ellipse is basically an elongated circle. The equation is similar, but not exactly the same. X minus h quantity squared over a squared, I'll explain what a is in a minute, plus y minus k squared over b squared, ditto for b, is equal to 1. Always equal to 1. Always. Okay, if it's not equal to 1, it's not an ellipse, it's not in proper form. It needs to be equal to 1. That will be important a little bit later on while we're trying to do stuff. The h and the k are still the same thing. H and k are the center of your ellipse. A is the distance along the x-axis, or along the x direction from the center to a vertex, and it doesn't matter which direction you go. It's A is going one way, A is also going the other way. Okay. B is the distance away from center along the y-axis to the y vertex. Okay. Unlike a circle, it's not, the radius is not the same. The distance from center is not the same. Now, an aside, this is not something we discuss in here, but this is actually something that's really cool about ellipses. Ellipses have 2 foci. Okay? The cool thing about the foci of or focuses, however you want to pronounce it, I don't really care, I don't care if it's correct or not, is the distance from one to the edge and to the other is the same no matter where along the edge you hit at. That distance of those two together is exactly the same. And the other thing that's really, really cool is that sometimes in very old, generally royal places, castles, things along those lines, royal ballrooms, they're in the shape of an ellipse. And at one focus, you have like a star or something special on the floor. At the other focus, you have another one. These are for spying and listening in on conversations. So if you wanted to hear what somebody thought about you, let's say you're the king or queen. Let's not be, you're the queen. Let's not be gender specific. My apologies. You would go stand on one star. You would have your confidant take your enemy and stand on the other star and have a quiet conversation about you. To have your confidant try to draw out the true feelings of your enemy. And they could be whispering, and you would hear them loud and clear as if you were in the middle of their conversation. So if you stood there quiet, and you're on one focus and they're on the other focus, you can hear straight up exactly what they're saying. Because everything that they're saying is hitting the wall and bouncing back to your spot on the floor. Because it works like that. Every place it goes, every sound, because sound travels in a straight line, it hits the wall and it would bounce back to the same spot. It's very similar to how satellite dishes work. It's the same concept. Everything goes and hits and lands in one spot. We'll talk about a bit more there. But you can actually see these spots in the floors, which is really cool.
Wait, where's that?
They're all over Europe, all over in palaces and such, ballrooms, things like that, meeting public places. Yeah, you can sit there, like I said, stand on one spot, and you can hear loud and clear what somebody on the other spot is whispering. You know, you can actually hear them better than if you were standing there with them sometimes. So you can listen in on other conversations. They're used specifically for those purposes. So I've just taught you how to spy on your enemies. Okay. So Find the equation of ellipse centered at the origin. That means our h and k are 0, meaning the following conditions: x-intercepts of plus and minus 4. That means our a is 4. Y-intercepts of plus or minus 3. That means our b is 3. So for the first one, we have x minus 0 squared, which is just x squared, over 4 squared, which is 16, plus y minus 0 squared, which is just y squared, over 3 squared, which is 9, equal to, what is it always equal to? 1. Always equal to 1. If it's not equal to 1, it's not an ellipse. And if it's not plus, it's not an ellipse. Ellipses are always plus. X squared, y squared, 1. Other things involved. And what makes them not a circle are these two values for a and b at the bottom. Okay, that's what makes it not a circle. Okay. So a little bit more difficult, but not that bad. Our center is here, so this is our h and k. Now what we need to do is figure out our a and b. If we sketch a little bit of what we're dealing with here, we're at 3, -1. There's our center. And our axes are at 1, -1. So 1, -1 is here. At 3, 4 is here. 5, -1 is over here. And 3, -6 is down here. We can figure out our a and b from those. Our a is this distance here. And we're going from 3 to 1. There's 1, there's 3. So our a is 2. And then our b is this distance here. And we can either go up or down, it doesn't matter. This is -1 on the y. And this would be -6 down here on the y. So we traveled how many units? 5. So our b would be 5. And like I said, you can go up, down, left, right. It doesn't matter which one. Just know your a is your x direction and your b is your y direction. So what do we have? We have x minus 3 squared over 2 squared, which is 4, plus y plus 1 squared over 5 squared, which is 25, equal to 1. Yeah.
Is the minor axis just a smaller one?
Yeah, the minor is a smaller axis. Good question. Minor axis, major axis. It changes direction depending on which one's smaller, which one's larger. Your foci are always along your major axis, so they could be oriented up and down rather than side to side. Doesn't matter. And we, for some reason, are not discussing the foci in here algebraically. I may look into that and change that. We'll see. Okay, graphing. Graphing isn't that hard. What do? You got to figure out the center. Got to figure out your A. Got to figure out your B. So my center on this one is what? 0, 0. The H and K, my center is 0, 0. My A is what? 3. And my B would be 2. Square root of it, yeah. So I plot it out. Go to the origin. I go 3 to the left and 3 to the right. -3, +3, up 2, down 2. And you just kind of draw a lopsided, Stewie. So you get that. Okay. What's our problem with B? It's not in standard form because it needs to be equal to 1. If it's not equal to 1, you make it equal to 1. Yeah, divide everything by 20. So I get x squared plus y squared over 10 is equal to 1. What is my x squared over for purposes of being an ellipse?
1.
Over 1. So our center is once again at the origin, which is nice. It makes it easy. Our A is what? 1. What's our B? Square root of 10, which is, I'm going to work this out, 3.16. So you do, for graphing purposes, you do need to be able to go, hey, I know about where it is. It's just a hair more than 3. That's okay. But you do need to know it's a hair more than 3. So I'm once again at the origin. 1, 1, a little more than 3, a little more than 3. Easy, right? Do this one. Okay, where's our center on this one? At 2, -4. What's our A? And our B is 4. So much better than my last class. I had like 2 kids answering every question. B equals B, B equals B equals B. Well, am I wrong? It's called the reflexive property. That's the reflexive property. You should remember that. Okay. 2, -4. And I go over 5. And I go over 5. And I go up 4. And I go down 4, which is just off. And I go around. Woo! Questions? Okay. A racetrack is in the shape of an ellipse 100 feet long and 50 feet wide. What is the width of the track 10 feet from a vertex? So, it wants to know that length between those 2 points from here to here. That's what it's looking for. Okay. So in order to do this, we can do anything we want. Let's make the assumption that our center is at the origin. Makes it easy, right? Putting the center at the origin makes it easy. I don't have an x plus or an x minus something. I can just assume that the center is 0, 0. Got to figure out my A and B. Well, how long is it this way, lengthwise? So what's my A then? 50. And if it's 50 feet tall, what's my B? 25. So my A is 50, my B is 25. My H and K are 0. So I can choose to put it wherever I want. I'm choosing to make the center of the origin to make life easy. So I have x squared over 50 squared, which is 2,500, plus y squared over 25 squared, which is 625. Yep. Equal to 1. There's the equation for my racetrack. Now, what I'm doing is I'm saying, all right, Specifically, what is my y value when my x value is -40? Because remember, here's 0. So I want 10 feet in, which means I'm going 40 feet from the center, right? So that means I let x be -40 or +40. It doesn't really matter, right? Because it's the same in either direction. And when I square it, it doesn't really matter, right? So that means I have -40 squared over 2,500 plus y squared over 625 is equal to 1. And I solve for y. That's what you have to do. You solve for y. So 40 squared is 1,600. The zeros cancel. So you get 16 over 25 plus y over 625 is equal to 1. Sorry, y squared. Subtract 16 25ths from both sides, right? Minus 16 25ths minus 16 25ths. Y squared over 625 is equal to 25 minus 16 is 9, right? 9 25ths. Multiply both sides by 625. And you get y squared is equal to 225. Square root both sides, and you get y equals 15. Now, is that the distance from end to end? No, 15 is here, 15 is here, so it's 30 feet across. Because it's 15 feet up from the center, that's what y is. Y is 15 at that point. But that's not the distance across. That's only halfway. Okay? You understand that? Once you get the equation, plug in one of the values you know, x or y, solve for the other one you don't know. That'll give you a coordinate on the edge, tell you the distances. Okay, uno más. You're installing a fireplace in your house. It has a flue with a radius of 4 inches. You have to cut an elliptical hole in the roof to accommodate the flue. If the pitch of the roof is 5/4, a rise of 5, a run of 4, what are the dimensions of the hole? So you've got a circular pipe that's 4 inches in radius, 8 inches across, going up through the roof. But the roof is not a flat roof, so you're not going to cut a circular hole. You have to cut an elongated hole to get your circular pipe through it. Make sense? What's the shape of the hole I've got to cut? That's what you're looking for. What is the shape of that ellipse? What are the dimensions thereof? Well, one set of dimensions is actually pretty easy. You figure you got the center about there, you got this distance and that distance. How wide is the pipe? It's 8 inches across, 4 inches in radius, so this is 4 inches here and 4 inches there. Because it tells you it's a 4-inch radius circular pipe. So the narrow section has to be it. It's only the angled section that has to be longer. Because when you're cutting in the roof, right, you're putting in your roof, you're cutting out a hole in your roof. This dimension across here is the same as the pipe. It's this dimension that's going to be longer, so the pipe's going to go through it anyway, right? And who says you don't do math when you get into construction? Now, here's what's really cool. This looks like it's a really, oh my God, nasty problem. How am I going to get the equation of my ellipse from this? You don't need to worry about writing out the full equation. It's not actually that hard. Here's what you got to remember. My roof has a 5:4 ratio. My roof has a 5-to-4 ratio. So I essentially need to figure out that length there. Now, a rise of 5, a run of 4 is similar to what do I have 8 inches for that? What's the diameter of the hole going to be? 8 inches. Remember, it's 8 inches across here because it's 4 inches for one of them, right? So 8 inches across, what's my height? So my roof has a pitch of 5-to-4. I'm going to go 8 inches across. How far do I go up to match it? 10. So I go over 8 and up 10. What's that length there going to be? So, gee, how might I figure out what that one is? X squared equals 10 squared plus 8 squared. X squared equals 164. X equals 12.81. So 12.81 by 8. So the dimensions of my hole are 12.81 by 8. So I got to go about 13, a little bit less than 12. About 12 and what's it, 7/8. 12 and 7/8 inches by 8 inches. Should actually be a chimney, not a flue, but it's flue and the chimney are the same thing. Okay, questions?